Hello students, in this video lecture I am going to discuss the instant insanity problem and its solution by using the techniques of graph theory. Now firstly, the question is, what is the instant insanity problem? Now instant insanity problem is a problem about cubes like these. You can see here there is a cube which has been painted with four colors. The faces, there are six faces of the cube, 1, 2, 3, 4, 5, 6, and these six faces have been painted with four colors: red, blue, green and white. So there are four such cubes that you have in the instant insanity problem, and the faces of four such cubes are painted with four colors: blue, green, red and white. And the pattern of colors can be in any order, or the number of faces that are painted with these colors can vary. But basically these four colors are used to paint the faces of the cube. And now the point is that you have to place these cubes, these four cubes, one above the other. You have to stack them one above the other in such a way so that the resulting column which is formed as a result of placing the cubes one above the other, the four cubes one above the other, if you see the resulting column, there will be four faces of the resulting column: one face at the back, one face in the front, one face on the left side, one face on the right side. So when you see these faces, you should be able to see four different colors, that is red, blue, green and white, on each of these faces. So each of the four different colors should be present on each of the four faces or four sides that you have for the resulting column. That is the front side, the back side, the left side and the right side. So this is the instant insanity problem. So basically the instant insanity problem is that four such cubes will be given to you, painted with four different colors. In this case we are taking the four colors to be red, blue, green and white. You can take any four different colors. Also the pattern of the colors can be any. I'll be just taking one version of instant insanity problem, in which I'll take four particular cubes, and they'll be there. The faces will be painted in some particular manner using these four different colors. And the problem would be that how should you place these four cubes one above the other? How should you stack them one above the other so that when you see the four sides of the resulting column, there will be a column that would be formed. So when you see the resulting column, the four sides, the front side, the back side, the left side and the right side, on these four sides you should be able to see the four different colors. Each of the four different colors should be there. So how should you stack them? How should you place them? So that is the instant insanity problem. Now as I already said that we are going to solve this instant insanity problem using graph theory. And before I actually go on to the instant insanity problem, let me just give you an overview of what graph theory is all about, and then we can proceed on to solving the instant insanity problem using graph theory. So now as far as graph theory is concerned, graph theory is all about diagrams which consist of vertices. These vertices are nothing but their points. These are the vertices, and these vertices are joined by lines which are called edges mathematically. So graph theory deals with such kind of diagrams which have two basic components. These components are points which are called vertices mathematically, and these vertices or points are joined by lines which are called edges mathematically. So any graph would have two basic components. One is vertices, or this is the plural form. The singular form is vertex. When you are saying it's one point, then it is one vertex. Otherwise, if there are more than one points, then we refer to them as vertices. And then lines joining them. This is the first component. The second component are lines joining them, which are called edges mathematically. Now, when you are drawing a graph, it is not important where the vertices are placed, where the points are placed. They can be far, they can be close. Also, it is not important how the edges are drawn. The edges can be straight lines, they can be curved lines. What is important is in a graph whether or not two vertices are joined by an edge. So that is what is important in graph theory. So this is just an overview of what graph theory is all about. Now coming back to the instant insanity problem. Now, coming to the instant insanity problem, as I have already mentioned that the instant insanity problem deals with the four such cubes, the faces of which are painted with four different colors: green, red, blue, and white. And the problem is that you have to stack these cubes, or you have to place these cubes one above the other in such a way that the resulting column which is formed, the sides of that resulting column, the front side, the back side, the right side, and the left side, on each of the side you should be able to see each of the four different colors: blue, green, red, and white. That should happen. So that is the instant insanity problem. Now we have to solve the instant insanity problem using graph theory. So if we have to solve this problem using graph theory, we should be able to somehow form a corresponding graph which relates to this problem. So we should be able to model this problem as a problem of graph theory by forming a corresponding graph, and that can be done by just converting this three-dimensional cube into a two-dimensional structure by opening it up and by flattening it. So what I do is along these edges which have been marked with slanted lines, so along these edges I cut the cube just along these edges which have been marked with slanted lines: this edge, this edge, this one, this one, this one, this one. So I cut along these edges and I just open it up, and I try to find out what is that I finally get after cutting it out. So this face has been marked as top face, the B face with blue color. Then this is the back face with red color R. This is the front face with red color R. This is the right face with green color G. This is the left face with the red color R, and this is the bottom face with white color W. So let me see, when I cut this whole thing out and I flatten it and I open it using scissors, finally what do I get when I cut along these edges which have been marked with slanted lines. So you can see that this is the final structure that has come out after cutting along the edges which have been marked with slanted lines in the cube. The final structure after cutting out and after opening and flattening the three-dimensional cube is this. So this is one cube that we have in instant insanity problem. There are four such cubes that we have in instant insanity problem. Of course, the faces are covered with four colors: green, blue, red, and white. But the pattern can be different. The number of faces that have been colored with a particular color that can be different in different cubes. So but four such cubes will be there, and we will open them out. We will cut them along edges like this, and we will open them up and we will flatten them, and finally four such structures will be obtained. So this is what we have next in the version of instant insanity problem that I am taking. The four cubes, after cutting out along these edges and after opening them up and flattening them, these are the four structures that we have. So these are the four cubes that we have in the instant insanity problem that I am considering, and these structures have been obtained by cutting along the edges of the three-dimensional cubes that you had in the beginning. So we cut along these edges the way I did for the bigger cube, and then we have opened these cubes up, and so these are the four different cubes that we have: cube 1, cube 2, cube 3, and cube 4. And if we just try to pick up cube 1 and if we try to recreate the original three-dimensional structure that we had in the beginning, so this is the three-dimensional cube that you had in the beginning, and it has been cut along the edges, and it has been opened up and flattened in the form of this two-dimensional structure. So now we are in the position to just model the whole problem as a graph theory problem and solve it using the techniques of graph theory. So let me form the graph corresponding to the instant insanity problem. Now to form the graph corresponding to the instant insanity problem, we will consider each of the four cubes one by one. So I have taken cube 1. Now this is the two-dimensional structure of cube 1. Now because there are four colors in this cube, and in each of the four cubes there are four colors: red, blue, green, and white. That is R, B, G, W. So in the corresponding graph there will be four vertices, and these four vertices represent the four colors, that is blue, red, green, and white. Randomly I am giving them names, or randomly I am labeling them. Now between two vertices there will be an edge if in the given cube the corresponding colors are opposite faces of that cube. So I repeat, between two vertices there will be an edge, or there will be a line if the corresponding colors are on the opposite faces of that cube. So for example, if we see cube 1, now in cube 1, red and green, these are opposite faces, because if we fold the cube, this is on the right side, this is on the left side, so these are on the opposite faces of the cube. So there will be an edge between R and G, because red and green are on the opposite faces, and I'll mark this edge with 1 because this is coming from cube 1. Same goes for this R and R, because these are again the opposite faces. This is the front, this is the back, so there will be an edge between R and R, which means an edge between R and R means that there is going to be a loop at this vertex. It starts from R and it ends at R, and again this pair of colors, which is blue and white, again they are opposite faces, because this is the top, this is the bottom. So again there will be an edge corresponding to B and W. So between B and W again there is going to be an edge. So this also will be labeled as 1, this will be labeled as 1. Since these three edges are coming from the cube 1, so we are labeling them as along the edges we are writing 1, because this tells me that they are coming from cube 1. So there are three edges that we get corresponding to cube 1, and these three edges represent the opposite faces in cube 1. So this is for cube 1. The same thing has to be done for cube 2. Again, if we take a look at cube 2, now this is cube 2. Now there is going to be an edge between W and G in for cube 2. Again there is going to be an edge between B and W for cube 2. Again there is going to be an edge between G and R for cube 2. And then for cube 3, again for cube 3 the same thing goes. There is going to be an edge between R and W, between B and R, between W and G. And then for cube 4, there is going to be an edge between W and B, B and R, and G and G. This is a loop that we have at G and G corresponding to cube 4. So correspondingly, this is the final graph that we have. If we just form the whole graph finally comes out to be like this. In a systematic way, I draw the graph. So this is what we have, and here, and this one, and this is for this is for 2, this is for here, let me write 1 over here, this is for 4, this is for 3, this is for 2, this is for 4, and this is for 2, this is for 3, and there was a loop at G, of course, this is for 4. So this is the corresponding graph that we have. There is no special reason why we have drawn the graph. These curved lines have been drawn. You can draw the lines in any manner, but this is just one way of drawing the graph. What is important is which vertex is connected to which vertex, and what is the number that is attached to the edge. So this edge comes from cube 2, this comes from cube 1, this is from cube 4. So let me just check. There should be 3 edges from each cube. 1 1 1, there should be 3 ones, there should be 3 2s, 2 2 2, then 3 3, and the other 3 is this one 3, and then 4 4 4 is this one, and 4. So this is the graph that we get after forming all the after just constructing all the edges. This is the final graph that we have corresponding to the instant insanity problem. Now once the graph has been formed, the next step is finding out a subgraph of this graph. Now what do you mean by a subgraph of a graph? Now a subgraph of a graph G, if G is a graph that is given to us, and if we want to find out a subgraph of the given graph G, then a subgraph is a smaller graph which is a part of the graph G. So which means that the vertices and the edges of a subgraph, let me call that subgraph as G1. So vertices of G1 and the edges of G1 come from the graph G. So the way we have subset of a set, in a similar manner we have subgraph of a graph, where the subgraph has vertices and edges coming from the graph, whichever underlying graph we have in the context. In this case, if the main graph is called G, then the subgraph G1 of G will be a graph in its own right, having vertices and edges, some vertices, maybe not all vertices, and some edges from the graph G. So we find a subgraph of this graph corresponding to the instant insanity problem, satisfying certain conditions. This is the second part of solving the instant insanity problem. So coming to the second part of solving the instant insanity problem. Now this is the graph corresponding to the instant insanity problem. Now in this graph which corresponds to the instant insanity problem, we have to form a subgraph G1 of this graph which satisfies certain conditions. And what are those conditions? Now a subgraph G1 has to be constructed from this graph in such a way so that three conditions are satisfied, and those three conditions are that G1 firstly should have all the four vertices of this given graph. This is the first condition, which means that G1 has four vertices, B, R, G and W. Then the second condition is that G1 should have exactly one edge from each of the four cubes. There are four cubes that we have in this problem: cube 1, cube 2, cube 3, cube 4. So G1 should have exactly one edge from each of the four cubes, which means that G1 has four edges. So G1 has four vertices, all the four vertices are there, R, B, G, W, and then it has four edges. G1 has four edges, one edge exactly from each cube. And then the third and the last condition that G1 must satisfy is that on every vertex that we have in G1, either exactly two edges are incident, or two edges are falling on a particular vertex, or on a vertex in G1, one loop is incident. Either exactly two edges should be incident, or two edges should fall on a vertex in G1, or one loop should be incident on a vertex in G1. So this should happen in the subgraph G1. Now we have to construct a subgraph G1 in such a way so that these three conditions are satisfied. And one way of constructing the subgraph which satisfies these three conditions, this is one way. Just consider this edge, and then consider this edge, and then consider this edge, and then consider this particular edge. Now these highlighted edges, these four highlighted edges, these form a subgraph G1 which satisfies all the three conditions that we have mentioned. This subgraph G1 with these four highlighted edges, we can see that in this subgraph G1 all the four vertices are there, B, R, G, W. Then there is exactly one edge from each of the four cubes. This is an edge in cube 1, this is an edge in cube 2, this is an edge in cube 3, and this is an edge in cube 4. Also on every vertex that we have in G1, there are four vertices, two edges are incident or two edges are falling. On B, on R, on G and on W, there are two edges which are falling. So all the three conditions are satisfied. Now once G1 has been constructed in this way, now the point is, what is the significance of this subgraph G1? What does it signify? Now if we just pick up an edge in the subgraph G1, let's say I pick up this particular edge. Now we can see that this is an edge in cube 4, and the endpoints or the end vertices of this edge represent the opposite faces in cube 4. The same thing goes for this particular edge. This is an edge in cube 1, and these two represent the opposite faces in cube 1. This is an edge in cube 3, and these two represent the opposite faces in cube 3. And this is an edge this is an edge in cube 2, and these represent the opposite faces in cube 2. So in a way, this G1 is giving me opposite faces in each of the four cubes: cube 1, cube 2, cube 3 and cube 4. So G1 actually represents an arrangement of these cubes: cube 1, cube 2, cube 3, cube 4, in which there are opposite faces. There is a pair of opposite faces from each of the four cubes. So we can represent this subgraph G1 somewhat like this. So this is the arrangement which the subgraph G1 is giving. So if you just stack the cubes one above each other, let's say this is cube 1, this is cube 2, this is cube 3 and this is cube 4. I am placing over cube 1, I am placing cube 2, over cube 2 I am placing cube 3, over cube 3 I am placing cube 4. So the subgraph G1 actually gives me an arrangement
or it gives me sort of opposite faces that we are getting from each of the 4 cubes. For example, let's say I pick up this edge which is in cube 1. So this edge, the end points or the end vertices of this edge are opposite faces in cube 1, which is B and W. So B and W I can write like this. Let's say I write W and B, something like this. And then in the edge, in this particular edge which is in cube 2, again red and green have been joined together. So red and green, these are again the opposite faces. And then in cube 3, this is green and white, so this is green and white. And then in cube 4, this is blue and red, so blue and red. So these are the opposite faces that we have. This is in cube 1, this is in cube 2, this is in cube 3, and this is in cube 4. So these are the opposite faces, and this is what the subgraph G1 is representing. Subgraph G1 is actually giving me a sort of arrangement where if you stack the cubes in this order, above cube 1 you have cube 2, above cube 2 you have cube 3, above cube 3 you have cube 4. So this is so there will be a resulting column that will be formed. We know when you stack the cubes one above the other, you will have a sort of resulting column in which there are 4 faces: the front face, the back face, the right face, and the left face, or we can say the front side, the back side, the right side, and the left side. So these are actually the opposite sides of the resulting column that is formed when the cubes are stacked one above the other. So you can regard this as one side. Let's say I am regarding this as the front side of the resulting column which you get when the cubes are stacked one above the other. And if this is the front side, then this represents the opposite side, which means that this represents the back side. So this is an arrangement that we get from the subgraph G1. So this gives me a way of stacking the cubes, or this gives me a way of placing the cubes one above the other, so that there are 2 sides that we have, and those two sides are opposite to each other, and they have all the 4 colors. You can see all the 4 colors are there, and one color is coming from one cube. So all the so basically this is an arrangement that we have of this resulting column that we were supposed to form by stacking the cubes one above the other. But then the same thing, the same arrangement has to be found out for the other 2 sides also, because when you stack the cubes one above the other, cube over cube 1 you have cube 2, over cube 2 you have cube 3, over cube 3 you have cube 4. There are 4 sides that you have: the front side, the back side, the right side, and the left side. So one arrangement for one pair of sides, let's say the front side and back side, we have found out by constructing the subgraph G1. But there are other 2 sides also for which a similar arrangement has to be found out, for the right side and for the left side, which means that to find out a similar arrangement for the right side and the left side, so that all the 4 colors appear on these opposite sides, we need to find another subgraph. Let's say I am calling that subgraph as G2. And G2 will be constructed from this particular graph only, which represents the instant insanity problem. But although G2 has to be constructed in a similar manner the way G1 was constructed, but G2 has to be constructed in such a way so that it is edge disjoint with respect to G1, which means that G2 and G1 should not have any edges in common, because the edges which have already been considered over here cannot be considered again in G2, because corresponding to this arrangement we have to find an arrangement for G2, because the right side and the left side will be formed after the front side and back side have been decided upon. So we have decided upon the front side and the back side. So accordingly the right side and the left side will now be decided upon how to stack the cubes by forming another subgraph G2. But G2 has to be formed in such a way so that there are no edges in common between G1 and G2. So these two should be edge disjoint, which means that one way of constructing the subgraph G2 is this. Let's say this is one way of constructing the subgraph G2. So now these highlighted edges, the edges which have been highlighted in blue, we can see that this particular subgraph which has highlighted edges in blue satisfies all the three conditions which G1 was satisfying. It has all the four vertices. G2 has all the four vertices. It has one edge exactly from each cube, from cube 1, from cube 2, from cube 3, from cube 4, and also on every vertex two edges are incident. And this is the arrangement which we are getting from this particular, by considering graph G2. So the arrangement is like this. So if you consider this as your, if you stack the cubes one above the other like this, if this is for cube 1, you're above cube 1 you have cube 2, above cube 2 you have cube 3, above cube 3 you have cube 4. Then because front side and back side have been decided upon by considering the subgraph G1, so right side and left side, let's say, can be considered as these two columns. And how are the colors given? The colors are given by just taking the edges, the end points of the edges of this particular subgraph G2. So in G2 you have this edge 1, so which joins R and G, so R and G. Then 2 which joins G and W, and then 3 which joins B and R, so B and R, and then you have 4 which joins W and B. W and B. I can't write B and W. I could have written B and W, but then B and B should not be there. You have to just decide upon how, in what order the colors have to be written. The colors have to be written as W or B or W, because every color can appear exactly once on this particular side. So I can't write BW, because if I write BW, B will come twice. So that is why I write WB. So you have to make so you have to adjust the colors so that all the colors, all the 4 colors appear exactly once. So you have to decide upon in which order you have to write the colors, whether you have to write WB or BW or BR or RB, whatever, so that on a particular face you have all the 4 different colors appearing once and exactly once. So this is the right side, this is the left side. So this is one arrangement that we have when you have decided upon the front side and the back side, which are given by subgraph G1. The right side and the left side will be given by the subgraph G2. So we can actually follow, practically we can follow this particular arrangement and stack the cubes to give a solution to the instant insanity problem. So let me try to find out the solution to the instant insanity problem that we were trying to solve. So I have again joined the edges back for all the 4 cubes that we took. This is cube 1, this is cube 1, and this is cube 2, this is cube 3, and this is cube 4. I have joined back the edges just by using a sellotape, and I have reformed again. I have just formed the cubes again. This is cube 1, cube 2, cube 3, and cube 4. And now let me stack these cubes one above the other. Above cube 1 I will put cube 2, and then above cube 2 I will put cube 3, and then above cube 3 I will put cube 4 to form a resulting column like this. And let me see what do I get when I use this particular arrangement which I have gotten G1 and G2. Now using this particular arrangement of the opposite faces that I have got using the subgraph G1 and subgraph G2, I have just stacked the cubes over each other. This is cube 1, this is cube 2, this is cube 3, and this is cube 4, and I have held them intact by using a tape. So you can just see that this is the front face of this is the whole resulting column that we have got. This is the front face of the resulting column, and the front face here it was WRGB. So this is WRGB, and then front face, and then the back face. So back face, if we see, this is BGWR, BGWR. So this is the front and this is the back. And now the right side is RGBW, RGBW, and the left side is GWRB, GWRB. So this is one such solution that we have found out for the instant insanity problem using the techniques of graph theory, and these were the cubes that we have taken in this version of the instant insanity problem. But the moment you change the pattern of colors in cubes, in these 4 cubes, although the solution, the method for solving the instant insanity problem remains the same, but the solution may exist, or it may not exist, or maybe more than one solutions exist for the instant insanity problem. But this is how you have to proceed to find the solution to the instant insanity problem, in which 4 cubes are given whose faces are covered with or whose faces are painted with 4 different colors, and you have to stack them in such a way so that all the 4 colors appear on all the 4 faces that we have: the front face, the back face, the right hand side face, and the left hand side face. So this is one solution that we have found out for one version of instant insanity problem that we have considered in this video. So that was all about the instant insanity problem.